everyone, we're PitPundit, and we minimize pit stops and maximize tire age. So, PitPundit is a total tire tracking software. It is able to track your F1 car's tires throughout each lap of the race and give you a certain chain of action to help you cross the finish line as fast as possible. We have cameras taking pictures of your tires at every stage, every lap of the race, and we're pushing all of that data on how soft the tire looks, or what type of tire is being used, what's the track temperature, what is the tire temperature, how many grooves are in the tire. All of that data is being recorded and put into various machine learning algorithms that are very complex and come out with one sort of plan of action or chain of action that you can take to help you cross the finish line as fast as possible. That's basically a short intro to PitPundit. My friend Zane will now show you the camera system.
Hello everyone, I'm Zane, and right now what I have in front of me is our embedded side of our project. What I have is a Raspberry Pi which is being hooked to a camera. In our case, the camera is going to be a high-speed camera with a higher shutter speed. Camera is responsible to capture all the images of the tires. The F1 cars are going to be like blazing fast, so that's why in our case the cameras needs to be like really high-speed cameras. Once the photos are being captured, the photos are going to the Cloudflare database, which is R2 object storage. We'll be giving you guys the demo shortly. Yeah, that's the R2 storage where all the photos are going lap wise. So once the photos are being captured, we're also processing such that only the tire specifically is being captured, because we don't want the entire body to be used by the Gemini model, which we're using to evaluate how the model is, like how the tire is, either is bad or good. Now my friend will be giving you guys a quick demo.
Bardhan, and I'm here to discuss the heart of our program. What actually happens after we take pictures of those tires from that camera. As we told you, we're sending that to a cloud-based database where we can access them at any time. What we're actually doing is we're taking advantage of Gemini's computer vision capabilities to seek out any sort of visible patterns on the tire. Anything that's visible, we're extracting. Any sort of visible information, we're extracting. Those generally include tire type. F1 tires, in F1 language, it's called a compound. So what sort of tire compound is it? Is it soft? Is it hard? Is it wet? Is it intermediate? These are various sort of different type of terminologies that they like to use to describe their tires. What sort of wear pattern, what sort of sidewall deformation is happening in the tire, what sort of graining is happening. Anything that's visible, we're extracting. But what about stuff that usually requires expensive sensors? I mean, to a F1 team, that might not be too much of a deal, but to a small team like us, we aren't capable of just using a expensive sensor to calculate the temperature of a F1 tire, or the track temperature, or the air pressure. So what we did is, using whatever information we could gain from our computer vision capabilities of the Gemini model, we started to reverse engineer the rest of the values, such as the temperature and the pressure, using physics-based models. Just to give you a short example of what we actually mean by this is, tire compounds are generally used within a certain temperature ranges. So if you have some specific tire compound being used, there's a specific temperature that compound tire is being used for in F1 logic. So that way we were able to kind of accurately predict the temperature of the track, or the temperature of the tire, by looking off what compound that tire actually belonged to. Something else is what the wear pattern looks like on the tire. If the wear pattern is very centered around, we can tell that the tire has a lot of high pressure. If the tire is graining a lot, then we can tell that the tire is too cold. Also, just by looking at the graining of the tire from the Gemini's computer vision capabilities, we can also accurately predict the temperature of the tire. Because if a tire is too grained, that's usually because the tire is cold. So that way we were able to synthesize data points using physics-based equations and F1 logic for temperature, tire temperature, track temperature, and tire pressure, because those sensors are usually very expensive. On the other hand, after we calculate all of this data on tires, on the F1 tire, we send it to our decision tree classifier and random forest classifier. Both are machine learning algorithms, which were trained on these accurately synthesized data points by our physics-based equations. So these machine learning algorithms just give us a course of action that we can take depending on what sort of tire condition we're at. And in this case, in this lab, it seems like the best strategy to go for is just keep monitoring your tire. As I told you guys before, these classifiers are trained on our accurately synthesized data points from our physics-based calculations and F1 logic. Their insights are usually very helpful. In this case, for lab 2, depending on the tire condition, we were able to extract from the computer vision capabilities, and again, synthesizing some from math, we realized that the best course of action to do is now monitor and just keep monitoring your tires while you're on the track as a driver. And now to go deeper into the AI insight of how you can even maximize your tire usage and based on what track you're at, I'd like to call my friend Dr. Wang.
So next up is our AI Insights in our dashboard. AI Insight is basically powered by a large language model, specifically Google's Gemini 2.5 model, which uses parameters such as track conditions like the track layout, temperature, and the time of the day to just give you an insight on a specific snapshot of a specific lap. And this is going to be somewhere around how the driver should react in the further laps from here onwards. And along with that is our other metrics such as the tire performance metrics for each of the individual tires and the snapshot list of time series of each lap.
Okay guys, that was it. This project mainly helps race engineers to understand all the data which is coming from all these sensors and provide all those data in a good way to the drivers to win the race, which is a mission critical process. So I hope you guys liked our project, and thank you for tuning in.